Hello, everyone. Welcome to Resilience in Action. Today I'm joined by Marybeth Arcodia. She's a assistant professor here at the University of Miami. You have a joint appointment at the Rosenstiel School for Marine, Atmospheric, and Earth Science, where we are today, and at the Frost Institute for Data Science and Computing. So welcome.
Thank you very much.
All right. So let's just introduce you a little bit. Talk about yourself, your training, your areas of research.
Yeah, so I know it's a mouthful, my dual appointmentship. So I'm with the Atmospheric Science Department here at Rosenstiel and then the Institute for Data Science and Computing, and that really is where my research lies. So atmospheric and data science combined. I like to describe myself as a climate scientist who uses machine learning and not the other way around. And so I am a climate scientist at the end of the day, but using these really emergent tools to capture complex patterns. I think when you look out the window and you see the ocean and the atmosphere and the winds, like it's a complex system. And so using these tools to help understand, using these data science tools to help understand the climate system is a main focus of my research here. So going back, I did my undergrad at Georgetown University and I majored in math. So I studied theoretical math and I've always enjoyed math. You know, I thought maybe I wanted to be an astronaut and things like that. But I wasn't exactly sure the path I wanted to go. Right after college, I was a volunteer in Chuuk, Micronesia. It's a 7 square mile island. I was a second grade teacher.
Wait, tell us. I'm pretty worldly. Tell us exactly where we could find Micronesia on a map.
So it's the Federated States of Micronesia. It actually spans the area of the United States, but it's about 1% of the land area. Okay. And so Chuuk is a state. It consists of 50 different islands. Closest to Guam, it's about a 2-hour flight southeast. And I was on the capital island of Weta, which is 7 square miles. So closest to Guam, and you can basically fly Hawaii through the Marshall Islands to Micronesia.
Okay. And so how did a mathematician end up in Chuuk?
So I wanted to spend a year volunteering, second grade teacher, so not really applying the math, the theoretical math from undergrad. But while I was there on this tropical Pacific island, we got hit by a typhoon and there was no warning. I was ready to go out and do my weekly grocery shopping. And so living on this island with very poor infrastructure, no warning for this typhoon that came through, really got my wheels spinning about extreme weather and the impacts of these extreme weather events. Seeing the island flattened firsthand where I was living, this community I was living in, just really started to inspire me. I came back to the US. I worked as an accountant for a year while I was looking at graduate school. So a bit of a quick non-conventional back towards conventional academic trajectory. And I started looking at atmospheric science. And, naively, I had no idea how much math went into meteorology. And so when I started to learn about this, as I started researching into graduate programs, it kind of seemed like this perfect fit, because now I could use the math that I really liked, but apply it to real world impacts, these extreme weather events. And, I applied here to the University of Miami. I came here for graduate school in 2016. Right. And that's kind of been the rest.
Right. But you left briefly and now you're back.
Yes.
Just take us through the last part of that journey.
So I did my PhD here 5 years. In 2022, I started a postdoc at Colorado State University. And there I worked with Dr. Libby Barnes, and I started learning machine learning in the context of applications for climate science. It sounds so fast moving, but this was before ChatGPT came out, even just a few months before, but it wasn't as household name as it is now. That was only 4 years ago. Right. And now it's everywhere, right. This explosion. And so I started learning these machine learning tools, applying them to climate science problems. So I was there. I did a postdoc for 2 years. I was a research scientist at Colorado State for a year and a half. And then in August of 2025, I came back here as an assistant professor.
Right. Um, Before we get off your biography, I know we have, the weather nerds out there will want to know, did the typhoon that leveled Chuk have a name so we can
Yes.
place it?
Yes, it was Typhoon Maysak,
Okay.
Maysack,
Okay.
and something that was so intriguing to me. So as I said, we had no warning,
Yeah.
but it also reflects the infrastructure that was there on this, very impoverished island.
Yeah.
When I was interviewing for the PhD here in Miami, I was telling people about this, and people here told me that they knew about this storm and that it was being forecasted.
Yeah.
And this light bulb went off that people in Miami were sitting and watching this storm, knowing that it was coming, yet the people on the island had no idea.
Yeah.
And this has been a driving factor for me. What good is a perfect forecast if no one heeds the warning? And so bridging between forecasts, improving forecasts, understanding the climate system, and actually communicating those forecasts is a main driver of my work that still comes rooted back to this.
Yeah. And I want to get to some of that part in a bit, but you and I have only known each other for, I don't know, 6 months or so. But one of the things that really intrigued me about your research was your work on subseasonal forecasts. So talk a little bit about what that is first, and then let's talk about how it might be applied.
Yeah, so subseasonal is roughly the time scale between 2 weeks and 3 months. So at 3 months, we get into seasonal. Below 2 weeks, we're on the weather time scale.
Right.
So, you open your phone, you see your weather app. Usually it's a 10 to 14 day forecast, usually with exact numbers, right? The high temperature here, our forecasts don't change very much, and some rainfall forecasts. On the weather timescale, we talk about these limits of predictability. So those forecasts are made by knowing the state of the Earth system. We run our forecast models forward in time, and then we know that we lose that predictability from that initial forecast about 2 weeks later. And so that's where the bridge, that's where the cutoff of our weather forecasts come.
Right.
When do we lose that information from the initialization of those forecasts?
Right.
On the seasonal timescales, we use a lot of information from our oceans. They're slowly varying. There's a lot of ocean memory. And so we have these longer signals in the ocean that we can use for our longer forecasts, things like the El Nino Southern Oscillation. And so subseasonal falls right in the middle. So it's this bridge between weather and climate. But because it uses information about the initialization of our forecasts, the atmospheric conditions and the ocean conditions, yet it falls right in the middle, we have the complexity of both, but the knowledge of neither, really.
Right.
And so for me, it makes it an exciting field, but it's also quite challenging. And so that's one of the reasons that it's fairly understudied, is because it lies at the intersection of weather and climate, ocean, atmosphere, land, all of these features. And again, that's something that really drives me towards this field, but also makes it challenging.
So if we come out with, as you come out with new products around subseasonal forecasting, who are you thinking about as end users? Who's going to use subseasonal? Who would use subseasonal in a way that would make a difference?
Yeah. So starting with the individual, maybe not as much, because we don't we can't use those exact number predictions, right? For 3 weeks out, to say 3 weeks from now it's going to be, well, here in Miami, 85 degrees would be a pretty good forecast.
Okay.
But, in general, giving those exact amounts. And so there can be a real disconnect in the digestion of that information.
Right.
Instead, a lot of planners, so decision makers at any level, can use these things. So, for example, if we have an increased risk of flooding, people here at the university could start to make preparation. Should we move, should we move some of our furniture inside? Should we lower dam levels? Should we lower pond levels? So water resource managers, electricity and energy managers, especially in things like heat forecasting. Here in Miami, we now have a heat season, heat resilience officer. And so people making those larger scale planning efforts, but even down at the individual level, thinking about maybe, if your energy bill is something that you're really concerned about, and conserving that energy as these things are coming is important.
Yeah.
So definitely local planners, it's important. Agriculture sector, it's very important for, especially they're so reliant on rainfall, but in the right amount. So too much rain, too little rain, too much heat, things like cold snaps.
Yeah.
And so, shipping also uses these forecasts out in the ocean. So it's really at all levels that it can be used. But I'd say for the larger scale planning, the idea with subseasonal and climate forecast is more lead time to prepare.
Yeah.
So anyone who's making those decisions.
As someone who's done a lot of, in a former life, I did a lot of event planning for when I was with emergency management. And yeah, like something like the World Cup, having those subseasonal to see what it's going to look like 3 or 4 weeks out. Are we going to get massive heat waves? What does that look like? I think that'll be really useful. I can also see it, the whole financial services sector. This is the link to ag maybe, but whether you're going short or long on particular commodities might be informed by subseasonal forecasting.
Yeah. And, the World Cup is a great example too, because the sports and financial elements that come with sports is so huge, these billion-dollar industries, and that those types of forecasts are important. It's multi-day, multi-week, that have thousands of people involved, billions of dollars. So that's a really good example. In sports in general, also it's impacted.
Let's talk more than just subseasonal now. I'm going to use the term forecasting, but I'm talking about the larger ecosystem of forecasting and risk modeling. Like, what are the changes that are going to come? You alluded to it. Machine learning and AI are definitely going to drive that forecasting field to be more accurate, quicker, more granular. I don't know. What can the resilience and emergency management worlds expect in the next 5 years, say? And then what other things do you think need to change in order for us to get more value out of that product?
So at the tools that are being developed, AI certainly, you hit on a lot of key pieces. We're seeing a step change in forecasting, which is a huge deal. So our forecasts for the past few decades have generally gradually increased, more research, better tools, better knowledge of the climate system, higher resolution. And so we've been increasing. But then the incorporation of AI into our forecasting, we saw a step change in the forecast skill, a step change that we haven't seen since the integration of satellite data.
Right.
And so to have that large of an increase is quite significant, especially, to be in the field during one of these step changes is exciting. Yeah. So we can expect to see we can expect to see increases. You mentioned the granularity, and that's a key part. However, there's also a lot of trepidation, still, tons of science going into this, research into the validation of these things. So we're trying to infill data, but how good is it? How well are we verifying down to that level? But hyper-localized is something that I spend a good amount of my time thinking about, trying to get down to the street level. What do people care about? This is key for resilience, right? At, local and larger levels, in terms of like, when is my street going to flood? Yeah. When does my heat bill become, or my AC bill become too high for me to be able to cool my home?
Right.
And so, these types of tools can really help with that granularity.
Yeah. So to that, I mean, so for the emergency managers, resilience planners, community planners that are doing work out there, given the changes in technology and data analytics that you see coming and the forecast nature that you just talked about, what are some of the things that they can do so that they make the most of this progress?
Yeah, I think there needs to be more communication. And that is sound like a broken record, of this communication of the forecasting.
Yeah.
And so as we integrate these new technologies, there still needs to be the communication of what we know and more importantly, what we don't know.
That's on your so that's on the forecasting,
Yeah.
prediction, analytics
Yes.
side.
Quantifying our uncertainty, which
Yeah.
is this broad term, but actually understanding when we're confident and when we're not.
Right.
So operational forecasting, they're putting out forecasts religiously, and it's such a benefit to the community to have really consistent forecasts. But some of those we know and we are researching when we have more confidence. Why do we have more confidence? Where do we have more confidence at that time period? So those are the things that as these tools continue emerging, and it will appear for good reason that things are improving, it still needs to be communicated what we don't know.
Right. But what, the second half of my question, though, is like, what can the communities of users, and I'm thinking less about the general public and more about the sort of level of government planners and private sector practitioners and others and community-based groups, how can they organize their data, their communities, their interaction with scientists like you in a way that allows them to get the most out of this step change in technological innovation?
Yeah, that's a great point. I mean, that's a great question because it's still it still comes back to the communication. So,
Yeah.
it's challenging to establish those relationships. But instead of the out of the box products is understanding. So there's a lot of, public service free products that are National Weather Service, Climate Prediction Center, all of them put out. And so, users of these tools, the communities that you're talking about, to be able to establish a relationship with their forecasters. And that's of course easier said than done. But in my experience, people working in these spaces want to engage with the end user. They want to be doing science that has an impact.
Yeah.
And so, actually bridging that gap is the challenge there,
Yeah.
but it benefits both sides.
And I know that's something that we're going to keep working on, over the next years. It's been a goal of Dean Kurtman's here. We've talked a lot about it. It's like, how do we really connect the folks who are working in the predictive and analytics space like you and the folks who are working on the ground in communities to like make communities future ready in some ways?
Yes,
and how do we bridge that gap? And I think we both agree there's no real silver bullet, but we got to keep leaning in some ways.
Things like the Climate Resilience Institute are fantastic for facilitating these types of relationships because that I see as a grand challenge. Is again this communication of the forecast, like I said, broken record.
Yeah. Let's talk about commercialization. So some of we're at this sort of disaggregating moment in weather and climate with the role of the federal government changing. So a lot of the stuff that we used to assume was for free might not be available in the same ways as it was. At the same time, you have lots of different companies who are mixing some public sector data and private sector algorithmic analytics in a way that spits out different kinds of forecasts and predictions. How do you think about commercialization from where you sit?
I see a role for commercialization, absolutely.
Yeah.
But I also see the role for the academic and public sectors. So I feel that the best case scenario is all of these different sectors existing, coexisting, and collaborating. And so, I really want to emphasize that there's private industries using public data that you just mentioned.
Right.
And without that public data, these industries or these companies don't exist or don't continue to exist.
Right.
And so this notion that we've been hearing about from higher ups about commercializing or privatizing the weather industry is just simply not feasible at the time being, especially at the cost that they're currently being offered at,
Right.
because the large majority of private weather companies are using free public data that's provided as a public good.
Yeah.
And so something I feel is that the benefits of this to the community need to be shouted from the rooftops because we are all benefiting.
Yeah.
Now, the commercialization of it, though, is really useful. So there's something to be said for taking public data and tailoring it so to an energy market, to a lot of stock trading.
Yeah.
We're going to reveal how little I know about the finance world here, but a lot of that trading, those types of things, markets, so different people using this information. And there is something to be said about pretty pictures, the visualizations that, they're able to put out that are, oftentimes way more visually appealing than the public data.
Yeah.
So there's roles for both.
Yeah. And I think, other than just tailoring, I also think like commercializing is a way of spreading the innovation that happens here. It gives it a life of its own. And now you have a startup that is on a mission to take the work and the innovation that you do here and bring it to communities or, private sector companies or, governments or whatever. So I do think that there's with all the caveats about that we need a strong National Weather Service, a strong NOAA, and a strong underpinning of free, publicly available data. There are reasons why commercializing may also help us move the needle in ways that make our communities safer, more resilient.
Yeah, we've already seen this like in my line of research where companies like Google, NVIDIA, they are building these AI-based weather and climate forecasting models that are just computational behemoths. And something like that is really infeasible on the academic standpoint. One, just from the time needed, from the money needed, yet they are publishing these open. And so we as scientists are able to use these models, run these models at a fraction of the cost. And that's a really great collaboration, coexisting of the private and academic sectors.
Yeah.
And another point I'll make is there's a major equity issue when everything becomes commercialized.
Yeah.
So the hurricane is coming.
Right.
And, it doesn't care the community that you live in. But we know without a doubt that lower income neighborhoods are more vulnerable to weather and climate disasters. And I am certainly of the thought that this information should be available to everyone, not just those who are able to pay for it. Now, certain sectors can pay for products that are tailored to them, yes, but there still needs to be public information for everyone, because the weather impacts everyone, and it impacts people disproportionately.
Yeah, that's a great point. We're close to wrapping up, but one of the things I want to touch on. You've talked a lot about the disruption that we're seeing. Unsurprisingly, I don't think anyone's going to be shocked by that sentiment. If you were, my 20-year-old son, what would you advise him or, the kids who are freshmen or sophomores these days? Is math skills still going to be like really important than the technical skills? Would you think more broadly? How are you thinking about how the disruption from machine learning and AI is going to affect workforce in your particular field?
Yeah. Also a great question. I think being in this space, I just wrapped up teaching an undergrad class. And so thinking really and interacting with people really thinking about these things right now. So I'm incredibly biased, but I think that math is super important and everyone should absolutely still be learning it. But that being said, AI tools are rooted in math, and so is all of our scientific field and so many other fields too. And because of math, are able to make these advances. So no doubt that these things are still incredibly important. Now with the emerging technology, there's a shift in the jobscape and all those things, but my ideas for people, 20-year-olds is still pursuing your passion. What gets you excited? What gets you interested? And then there's the tools that are emerging that will follow from that.
Yeah.
And so that's something that doesn't change. And so there's going to be new jobs available. There's going to be jobs that are no longer available, but still following that passion will be able to push you through disruptions in the market, disruptions in funding, or disruptions in your personal life, talking about resiliency. Yeah. And so, finding something that really drives you will always be key. So if that's math, then that's great.
Yeah. So yeah, I think that's really smart. Like, don't overcorrect for where you think the market is going. In some ways, follow your passion, and you'll find the path and the tools in order to make that a reality. I think that's great sentiment. There's so much to be nervous about these days: the geopolitical situation, the climate, the economic transition that we're about to experience. But what's most exciting for you in your field going forward?
There's so much passion still. So, we've had these disruptions even since I started in this field thinking about climate science, climate change, these existential threats. But I've seen so much passion from the younger generation just behind me that it feels really motivating to keep doing this work, to see that, there are, benefits, progress in the field of climate science. So something that I find really exciting is the puzzle piece element of understanding the climate system, trying to understand a new component, and then, doing this science that has an impact on people, an improved forecast, an improved communication, using new emergent technologies in this field is really fun. And sometimes it feels very overwhelming to try to keep up. I'm sure in this conversation, something new has come out. But, just making these and seeing, that there is so much motivation from the next generation to build a better planet. And so, that we're working towards something that will continue, despite all of the challenges. There'll be more to come, I'm sure.
Yeah.
But again, having the passion, my own passion, and seeing it in others, makes it really fun coming to work.
And it's certainly something that we can feel and experience, and it motivates us as well. So, Marybeth, thank you for being on Resilience in Action.
Thank you so much. Thank you for having me.
Great to have you.